This is lecture 24 in network theory. In this lecture we are going to discuss about two-port networks, right, or two-port parameters. Now, so in the previous lecture we have seen AC transients, so for RL and RC network, and in this we have found some conditions for transient free, right. So to make transient free, what is the conditions for either RL or RC network? And one point we have to remember is there is no transient free condition in RLC network, right? Whenever there is RLC network, series RLC, parallel RLC, etc., so we cannot find any transient free condition because two storage elements will be there, that is either inductor and capacitor. So both are storage elements. If both are present, so we cannot get any transient free condition, because always if it is taking the energy and it may give energy. Similarly, if it is giving energy, it may take energy. So always there will be a transient conditions, right? So we cannot get any transient free condition in RLC circuits, right? And for your information, I uploaded a problem sheet on sinusoidal steady state analysis in our blog. That is learningiseverything.blogspot.in, right? So please go through this. Then I have solved some problems and I have given some problems for you, and answers also I have given. So make sure that you practice and see that the answers are right or wrong, right? Now, what is this two-port network? Suppose if a circuit is like this, so some linear network is there, a network. If it is containing only one port, it is like a input port, right? So whatever the we have discussed for Thevenin's theorem, Norton's theorem, mesh analysis, all are the one port networks, right? So this is an example of one port network. Similarly, if I go to two port network, so it will have input port and output port, right? So for at input side we will have the input voltage V1 and input current I1. Similarly, at the output side we will have output voltage and output current. So we will have four parameters, right? So input parameters and output parameters. Now if I take this, what are the two port parameters, how many will exist? Suppose, so V1 I1 and V2 I2. So in these four parameters we have to take two independent parameters and two dependent parameters, right? So out of four, if two independent, so 4C2, so the arrangement, so it will be 4 factorial by 4 minus 2 factorial into 2 factorial. So we will get 6 different types of two port parameters. So what are those? So one by one we will see. So these parameters are called, first one is Z parameters or impedance parameters. Next one, Y parameters are admittance parameters. Next, H parameters are hybrid parameters. G parameters are inverse hybrid parameters. Similarly, ABCD parameters are transmission parameters. Small ABCD parameters are inverse transmission parameters. So sometimes they will ask small ABCD are A dash, B dash, C dash, D dash, right? So we have to discuss this one by one. So first I will discuss the Z parameters. So in this, V1 and V2 are dependent, I1 and I2 are independent. So this can be written like this: V1 is equal to Z11 I1 plus Z12 I2. Similarly, V2 is equal to Z21 I1 plus Z22 I2. Now how to find the Z11, Z12? Now if I make, first case, if I make I2 equal to 0 in both cases, so if I make I2 equal to 0 means the output side, output is open circuit. So I am making output side open circuit. Now if my output is open circuit, what I can find? V1 is equal to Z11 I1. That means Z11 is equal to V1 by I1, which is when I2 equal to 0. This is called, see, we are opening the output side, so this is called open circuit input impedance, right? Generally these parameters are also called open circuit impedance parameters. Similarly, from the second equation, V2 is equal to Z21 I1, which is Z21 Z21 is equal to V2 by I1 when I2 equal to 0. So this is also called open circuit. So again it is impedance only, but from output to input it is transferring, right? Open circuit transfer impedance, open circuit transfer impedance, right? Similarly, next, if I make I1 equal to 0, that means input side is open circuit, right? If input side is open circuit, so from this first equation V1 is equal to Z12 to I2, so it leads to Z12 is equal to V1 by I2. So when I1 equal to 0, so this is also called open circuit V1 by I2. Again it is a transfer impedance, right? So this is from V2 to, that is 2 to 1, that is output side to input transfer. It is input side to output side transfer, right? Next, same V2 is equal to Z2 to I2. So it is Z22 is equal to V2 by I2 when I1 equal to 0. So again it is also called open circuit. So V2 by I2, so output side, so it is output impedance, right? So these are the four parameters. Z11, that is V1 by I1, which is input impedance. Z21, it is transfer impedance from output to input. Z12 is also transfer impedance. It is from V1 to, input to output. The last one is Z22, which is V2 by I2 when I1 equal to 0, which is open circuit output impedance, right? Now, now how to make it in matrix form. So Z is equal to, we'll have four parameters always: Z11, Z12, Z21, Z22, right? Now before how to find the Z parameter, see, we will never use this method. This is generally we call standard method, right? So we don't use this method, so we will do in a different way to find the Z parameters. That we will see when we do one numerical. But before that, we need to discuss about symmetrical network and reciprocal network, right? So symmetrical network means a network is said to be symmetrical if input impedance is equal to output impedance. That is something like this, or generally we say the network looks same. Suppose if I am looking like input side, so if we see 1 ohm and 2 ohm, and if you see from the output side, it should also look same. That's like a mirror image, right? So whatever you are looking here, the same if we are observing here, so that is called symmetrical network, right? The network looks same from both input and output, then it is symmetrical. So to happen that one, so Z11 is equal to Z22 for Z parameters. Now similarly, see if you see this, so what is it is looking like? It is seeing 2 ohm and 1 ohm, and if you see here, it is also looking 2 ohm and 1 ohm. So this is a symmetrical network, right? So this is about symmetrical network. Next one is reciprocal network. Always we need to find the conditions for these two. So it's very simple. A network which obeys reciprocity theorem is called reciprocal network. So what is the reciprocity theorem? The I by V should be constant, or we can say response by excitation should be constant. Now what is the condition is all passive networks are reciprocal networks. That means it should not have any dependent sources, no dependent sources. If it is any dependent source it is having, so it may not be reciprocal network, right? So this is the reciprocity. That is, if I interchange, suppose this is V and this is I. At the output side we are getting the response I, and input side is V. If I interchange V and I, so there is no change in the I by V constant. So always I by V will be constant. So to make that reciprocal network, for using Z parameters, Z12 is equal to Z21. That is, transfer impedance should be equal. So Z12 is equal to Z21, right? Next we will see how to find this Z parameters. Now, so suppose this is some ZA, this is ZB, this is ZC. Suppose this is a network, two-port network. and it is having V1 I1, it is having V2 I2. Now don't use that, so make I2 equal to 0, then find V1 by I1, etc. Just apply the KVL or mesh analysis here. Now if you see, this is I1 is coming here, this is I2 is coming here. So what is this? I1 plus I2. If you apply KVL here, so V1 is equal to, see I1 is coming here and here. So if I take I1 common, it will become ZA plus ZB plus ZB into I2. Similarly, if I apply KVL in this loop, not like this, so V2 is equal to ZB into I1, because I1 is coming in this branch only, plus ZB plus ZC into I2. Now what is the rule is, just to find the relationship between V1 comma I1 and I2, similarly V2 I1 and I2, then we can find the Z parameters are like this. Z is equal to ZA plus ZB, and this is ZB only, and this is also ZB, this is ZB plus ZC. Now it is easy to remember. Whenever there is a network, T network, generally it is called T network. So to find Z11, so ZA plus ZB. Similarly, to find Z22, so ZB plus ZC, and whatever this one, this is common, right, for input side and output side. So here you get Z12 and Z21 is as same, right? Now it is very simple. Suppose this is some 20 ohms, this is some 30 ohms, this is some 40 ohms, right? Now what is the Z parameters for this one? If someone asks you, so don't find making I2 0, etc. So directly Z is equal to this, Z is Z1 is ZA plus ZB, so 20 plus 30, directly 50 ohms. So it is common for input and output, so it will become 30 ohms, 30 ohms. Now to find Z22, so we need to apply KVL here, that means ZP plus ZC, that is 30 plus 40, 70 ohms. Now to comment on reciprocity and symmetrical, Z11 is not equal to Z22, that means it is not a symmetrical network. But Z12 is equal to Z21, that is it is a reciprocal network. Okay. So always they may ask what is the conditions, or if the network is reciprocal, what is the Z12 or Z21 they ask. So this is about the Z parameters. Now we will see the Y parameters, or generally it is called admittance parameters, or also called short circuit admittance parameters. Why it is called short circuit? Now we will see. Suppose there is a network, it may be linear, I mean it is linear network. So this is V2 I2 B1 I1. Now if I make in this first case V2 0, so V2 equal to 0 means output we are making short circuit, right? So short circuit in the sense this is a short circuit, that means V2 equal to 0. Now from first equation I1 is equal to Y11 V1, so it leads to Y11 is equal to I1 by V1. So I1 by V1 is nothing but admittance, or we can say the units. In the previous case Z means ohms, now we will get mhos, right, or ohm inverse or mhos, right? So this is called, see, I1 by V1, so it is input admittance, Now how we are finding? It is called short circuit input admittance. Similarly, if I2 is equal to Y21 V1, so it leads to Y21 is equal to I2 by V1. So this is called short circuit transfer. See, transfer from I2 to V1, that is port 2 to port 1, transfer admittance, right? Similarly, if I make V1 equal to 0, that means input side we are making short circuit, that is like this. So I am making short circuit here, that is V1 equal to 0, and here we are finding the relationship between V2, I2, etc. This is I1. Now remember, when voltage is 0, so current may exist. So V1 equal to 0, from equation 1 I1 equal to y12 v2. So it leads to y12 is equal to I1 by v2. So it is called short circuit transfer admittance, right? Transfer admittance. Similarly, what is I2 is equal to y22 v2. From the second equation, it will leads to y22 is equal to I2 by v2, which is short circuit output admittance, right? So this about the y parameters. So again, so we don't find from this procedure, that is v2 equal to 0, etc. This is a standard procedure. Suppose if you are not able to write this mesh analysis and getting these equations, then only we can apply this procedure. So if I make a matrix form, so it will become like this: y is equal to y11, y12, y21, y22. Now for symmetrical network, condition is symmetrical network. What is the condition? The output admittance should be equal to the input admittance. Similarly, for reciprocal network, y12 should be equal to y2. So these two conditions to satisfy for the y parameters. Suppose, so this is the network is given. Suppose we need to find the y parameters. So this is a pi network, and these three are the admittances. Now to find the y parameters, so the standard procedure is, first we need to make short circuit this one, then find the relationship between I1 v1 and I2 v1, right? So this is somewhat different procedure. So if I use different procedure to find this one. So what is this voltage across parallel? It will be same, that is v1, and this is v2. Now if I apply nodal analysis and find the relationship between I1 with respect to v1 and v2, I2 in respect to v1 and v2. So it's very simple. If I apply nodal analysis at v1, so what is this incoming current? My I1. So if I assume all are leaving currents, minus I1 plus v1. So this is a grounded, v1 minus 0. Now if you see, this is admittance, that is for, but we need impedance. So that is v1 minus 0 by 1 by va is the impedance. Similarly, plus v1 minus v2 by 1 by yc equal to 0. Now see, if minus e1, that is going that side, so it will become I1 is equal to, if I take v1 common, it will become ya plus yc minus yc into v2. Now first equation we got. Similarly at v2, minus I2, because I2 is incoming, is equal to v2 minus 0 by 1 by yb, because I need admittance, impedance, plus v2 minus v1 by 1 by yc. Similarly, if this is plus, which is equal to 0. If I2 is going that side, so I2 is equal to minus v1 into yc plus v2. If I take common, it will become yb plus yc. This is equation 2. So from this, what is the y parameters? Y is equal to, see, I1 is equal to y11 into v1, so ya plus yc, and this is y1 to v2, so minus yc. Similarly, this one minus yc, and this is yb plus yc. That means if we see any network like this, if we know this ya and yc, yb, then the y11 will become ya plus yc, y22 will become yc plus yb, and the y12 and y21 should be minus of yc. So this is a standard network. So once you remember this one, we can find easily when we find the network like this. Suppose the question given like this: this is 1 ohm, this is 2 ohms, this is suppose 3 ohms. If I want to find the y parameters, now this is the impedances, so directly I can write like this: y is equal to, say, this is yc, this is ya, this is yb, so ya plus yc. Now but it is impedance, so it will become 1 by 2 plus 1 by 1. Similarly, this is yc, so it is common, so minus 1 by 1, so minus 1 by 1 minus 1 by 1, same. Now about the y22, it will be 1 by 1 plus 1 by 3. So it will be 3 by 2 minus 1, this is 4 by 3. Now about symmetrical network, so y11 3 by 2, but y22 is 4 by 3, so y11 is not equal to y22, so it is not a symmetrical. Similarly, if you see y12 is equal to y21, because minus 1 and minus 1 both are equal, so it is a reciprocal network, right? So this is how to find the y parameters, right? Next we will see the g parameter, hybrid parameter. Now we will see the hybrid parameters or h parameters. Why it is called hybrid means it is mixed parameters, that is it will have input impedance, output impedance, or admittance, or current gain, or voltage gain, everything will be mixed. Now what are the independent and dependent variables here is, dependent variables are v1 and i2, and independent are i1 comma v2. So these expressions we need to remember to find the all parameters. So v1 is equal to h11 i1 plus h12 v2. Similarly, I2 is equal to h21 I1 plus h22 V2. These hybrid parameters are very helpful in analog electronics, right? Because there we have to find the input impedance, output admittance, or and current gain or voltage gain, right? Now first we need to find the h11 h21, so we need to make V2 equal to 0. So when V2 equal to 0, that means output is short circuit. So when output is short circuit, so I can find h11 is equal to V1 by I1. So this is called short circuit input impedance. Next h21, so from this h21 is equal to I2 by I1. So this is called short circuit current gain, that is I2 by I1 is the output current by input current, so current gain. Similarly, to make a different remaining parameters, so we need to make I1 equal to 0. Now that is I1 equal to 0 means input side open circuit. So when I make input open circuit, I can find first h12. So this is h12. So h12 is equal to V1 by V2. So it is open circuit. See, output is in the denominator, so V1 by V2. So it is called a reverse voltage gain. So open circuit reverse voltage gain. Similarly, h22 is I2 by V2. So this is called open circuit. I by V means admittance, so but it is I2 by V2 means output admittance, right? Now again we need to see what is the conditions for symmetrical and reciprocal. So in symmetrical network, it is the det of h parameter is equal to 1. So suppose if I take h is equal to the parameters h11, h12, h21, h22. What is the det means? h11 h22 minus h21 h12 is equal to 1, or delta h is equal to 1. So this is the condition for symmetrical network. Similarly, for reciprocal network, it is h12 is equal to minus h21, right? h12 should be equal to minus h21. So this is about the hybrid parameters. Now if you see this one, so we are having input impedance, current gain, reverse voltage gain, and admittance. So it is a mixture of the impedance, admittance, and gains, voltage gain and current gain. So that's why it is called hybrid parameters, right? Next one is G parameters or inverse hybrid parameters. So it is opposite. See, in this we have taken V1 and I2. So what is opposite? So here you will get I1. So in place of V1 we will get input side I1 here. This is I2. So we will get V2. So I1 V2, which is equal to G11 V1 plus G12 I2. Similarly, V2 is equal to G21 V1 plus G22 I2. Now how to find the parameter? So first we will make I2 0. So that is output is open circuit. So in that case we can find G11 as I1 by V1. So this is called open circuit I by B, input admittance. Similarly, G21, it is V2 by V1. So it is open circuit voltage gain, that is output voltage by input voltage. Now to find other parameters, we will make V1 0. So V1 0 means input short circuit. So if it is input short circuit, we can find the parameter G12, that is I1 by I2. So it is short circuit, see, input by output, so reverse current gain. Similarly, G22, that is V2 by I2. right? So what is this? This is short circuit. V2 by I2 means output impedance, right? It is again the inverse hybrid parameters, means it is also contains admittance, gains and impedances, etc. Now same symmetrical and reciprocal networks as the H parameter. Delta G is equal to 1. So suppose G parameters matrix is G11, G12, G21, G22, right? So again delta G is equal to 1, that is G11, G22 minus G12, G21 is equal to 1. Now for reciprocal network, symmetrical network, reciprocal network, G12 is equal to minus G21 for reciprocal. Next we will see the transmission parameters or ABCD parameters. So these are the helpful when we do transmission lines. So whenever from input side to output side is transmitting, so what is the conditions, etc. So for that the independent parameters are V2 and I2, the output parameters, and the input parameters are V1 and I1, right? So why it is transmission mean? So if I give from the input side, so how much it is effectively transferred to the output. Now so this can be written like this: V1 I1 and A B C D. See, always these parameters are positive, only the V2 and this I2 will be negative. So what is the T parameter? A B C D. Now to make the find the parameters, so we'll make I2 0 first. So that is output is open circuit. If I find A, that is V1 by V2. So it is called open circuit voltage ratio, because the input voltage by output voltage ratio. So voltage ratio, right? Or we can say reverse voltage gain also, because V1 by V2. Similarly, C from the second equation, C is equal to I1 by V2. I by V means admittance. So that is open circuit transfer, because I1 and V2. So from input to output transfer admittance. Next one, to make other parameters, we will make V2 0. That means output side short circuit. So if you see, in both cases output is one time open circuit, one time short circuit. So the remaining parameters are B is equal to minus V1 by I2. See here, so this one B is equal to minus is minus V1 by I2. So that's why it is called short circuit negative transfer impedance. V by I means impedance, so transfer, negative transfer impedance. Similarly D minus I1 by I2. I1 by I2 means gain, but it is negative. So short circuit negative current ratio or reverse current gain. So right, that is also we can tell negative current ratio or negative current gain. Now if I take the T parameter ABCD, symmetrical network is generally it is called symmetrical when A is equal to D, right? So it is opposite of the previous inverse and hybrid parameters. For reciprocal network, it will this det of the transmission parameter is equal to 1. That is AD minus BC is equal to 1. Now the inverse transmission is same, but this is V1 I1. Now we will take V2 I2. That's why it is inverse. So V2 I2. So small a V1 minus B I1, C V1 minus D I1. So to find the parameters, so I will make I1 0. That is input open circuit. So I will get IA, that is V2 by V1, which is called open circuit voltage gain. Similarly, C means I2 by V1. I by V means admittance. So open circuit transfer admittance. Now to make other parameters to find, so we will make V1 equal to 0. That means input short circuit. So when I make input short circuit, I can find B, which is minus V2 by I1. V by I means impedance, but it is negative. So negative short circuit transfer impedance. Similar D means minus I2 by I1. I2 by I1 is gain. So negative short circuit current gain. So if I take this is T dash, generally transmission. So A, B, C, D. Same symmetrical network means A is equal to D. For reciprocal network, so det of this T dash is equal to 1. So AD minus BC is equal to 1. So these are the about the parameters, right? So if I make a summary on this, see, summary means, so for the Z parameters, what are the dependent parameters? V1 and V2. So it is V11 is equal to Z11 I1 plus Z12 I2. Similarly, Z21 I1 plus Z22 I2. Right? Now condition for symmetrical, Z11 is equal to Z22, Z12 is equal to Z21. Similarly, in Y parameters, what are the dependent is I1 and I2. So the parameters are Y11, Y12, Y21, Y22. So conditions for symmetrical and reciprocal. Similarly, H parameters. What are the dependent parameters? V1 and I2. So V1 is equal to I2 is equal to, we need to write the expressions, right? And the condition for symmetrical is delta H is equal to 1. Reciprocal is H12 is equal to minus H21. Next one, G parameters, opposite of this one. So V1 here, but I will take I1 here. So I1 is equal to G11 and V2 is equal to G21, etc. So V1 is equal to, so here H11 here I1 plus H12 V2. Similarly, I2 is equal to H21 I1 plus H22 V2. Similarly, here I1 is equal to G11, so first V1 plus G12 I2, right? Similarly, G21 V1 plus G22 I2. Same condition is for symmetrical is delta G is equal to 1 and reciprocal is G12 is equal to minus G21. Similarly, transmissional, inverse transmissions. So here V1 is and I1 is dependent parameters. So AV2 minus BI2. So V2 will come first. So that is AV2 minus DBI2. CV2 minus DI2. Similarly, V2 means here we will get AV1 minus BI1. So AV1 minus BI1 dash or small a. Small AV1 minus small BI1, etc. we will write, right? And but condition for symmetrical is A equal to D and small a is equal to small d. And for reciprocal, AD minus BC is equal to 1 or delta T is equal to 1. Small AD minus BC is equal to 1 for the reciprocal. So this is about the summary of this two-port parameters, right? Next we will see some problems, previous gate problems or some from the textbook problems we will solve from these parameters, right?